So what do we do with this? What do we do with this here? These kinds of questions. I can see why these are a little tough. Now, if they give us some triangle ABC, and they're telling us the lengths of two sides, right? And what they're asking us to do here is find the range of values that we could have for the third side that would make the triangle into the kind described. So they want this to be an obtuse triangle with these side lengths that are described for us. So if the missing side has to be less than the length of BA or AB, it's got to be less than 77. What's going to be the longest side in this triangle? It's going to be the longest side. It tells me AB is 77, BC is 85, and AC is going to be less than 77. So what's going to be the longest side? 85. Okay, so BC is going to be the longest side. Now here's how we want to do this strategically. We always want to compare this to a right triangle, because if this is going to be obtuse, we have to just nudge the right triangle a little bit to make it obtuse, right? So let's start off with a right triangle, like so, and let's make sure we label these vertices right. I know that these need to be BC, don't they? Because the longest side has got to be 85. So that's B, that's C, that leaves that one to be A. So we know that's 85. They tell us AB is 77. And our rubber band becomes this side down here. We'll call that X. That's the side that we're going to control. So here's the part that I think people have trouble with, is how do you know? If it's the hypotenuse that's the rubber band, it's easy. It's obvious. Then you just stretch the hypotenuse to make the angle that's the right angle. It's right now it's a right angle, but it may not be later, right? We make it obtuse, it's not going to be right anymore. But that's the big angle right there, isn't it? If the hypotenuse is the rubber band, obviously you stretch it to make that angle bigger and make the triangle obtuse. You shrink it to make that angle smaller and make the triangle acute. But if it's one of the other ones, it gets a little trickier. Well, it turns out it's always the opposite of the hypotenuse. But how do we might forget that. How could you do this? My recommendation is you draw two sort of extreme cases. If I make AC bigger, for example, let's just see what happens. If I stretch the rubber band out, and I know that the blue sides of the triangle are sticks, or they're boards, they're fixed. You can't stretch those, right? So here's my hinge. So here's my hinge up here. Right? There's my hinge, and so that's where this thing can flex. Now, if I make X bigger, if I stretch X out, if this is hinged right here, then would you agree this piece has to kind of, it's just going to move around. It's going to, when it tilts up, this point C is going to kind of move in a circle. Does that make sense? It's going to do something kind of like this. This point C is just going to, it's going to move up either sort of in that direction or down in that direction, right? If I stretch this thing out, I make it longer, there's one of two things that can happen. Either the rubber band is going to end up being up here, or it's going to end up being down there somewhere, right, if I make it longer. Which one of those makes sense? Which one of those two scenarios could fit with our hinge and our boards? The one going down? If this one, if the rubber band stretches and that causes it to move down, isn't that going to force this blue piece that's now 85 to get a lot longer? See what I'm saying? That doesn't work, does it? When I rotate this thing down, I'd have to stretch it out to get to that point. You see my point? No. But let me say that again. If I'm going to stretch the rubber band out, I know that this angle is either going to get bigger or smaller, isn't it? If the angle gets smaller, then doesn't that mean that the rubber band is going to end up being up here? Right? That angle right here is a little bit smaller than the right angle, right? If the angle gets bigger, so that angle gets bigger, it becomes obtuse, then that means that the rubber band is going to bend down this way, right? It's going to get pushed down this way when I stretch it. Well, that can't work. That can't work because if the rubber band is going to be moving downward and stretching, that's going to require this piece to get longer than 85, which you can't do. You see my point? if the rubber band is going to, if the rubber band gets longer, it's going to have to move up because that's one that the hypotenuse could reach. Right? Going from there out to there means it can still be 85. Get my point? Right? Let's look at the opposite effect. Oops, I want to do that. Let's do that. Hey, ladies, do we need to move? We're okay? Okay, so if the rubber band shrinks, if it gets shorter, right? If it gets shorter, let's say it becomes like this long instead of that long. One of two things happens. Either it's going to make this angle smaller, so it's going to go like that, or it's going to make it bigger and it's going to go down there somewhere, right? Which of those two things would fit? If this is my hinge, which one of those two things could this top segment rotate down to do, or rotate up to do? That's not going to work, is it? Right? From there to there is too short, but from there down to there, that's okay, isn't it? That could work. You see my point? So you can just kind of test out two values if you wanted. If you're looking for some kind of a mathematical equation, there just isn't one. A lot of geometry is like that. A lot of geometry is just, you just have to kind of play with things in your mind a little bit, see spatial relationships and angular relationships. It's a good thing to practice because getting good at that is very useful, right? But and maybe you'd rather just do it this way. Maybe you'd rather just kind of think about what's the effect going to be of stretching or shrinking that rubber band. If I stretch it, you can kind of visualize it. If I stretch it, it's going to have to open this thing up, isn't it? Right? Because this has to stay the same and that has to stay the same. So if I stretch the rubber band, this is definitely going to make this angle smaller, right? If I stretch this rubber band, the orange side is becoming more like the hypotenuse, isn't it? It's becoming bigger. So the other angles have to get smaller, right? If I shrink it down, look at the extreme cases. If I shrink it way down, then this angle gets really big, right? This angle in here. Okay? Does that make sense? I mean, it may not until you actually sit down and just kind of do some problems. But you just have to sort of just stare at it and think about it a little bit. But the only question you're really asking yourself is, am I going to have, if I want to make this thing obtuse, am I going to shrink or stretch the rubber band? One of the two things. Pick extreme cases. Make it really short or really long to see, and it's easier to see what's going on. If I make this thing really short, obviously it's not going to be making this angle smaller because that's not going to work, right? That point is too close to be. It would have to be getting further away, right? Okay, so what's the answer? Good point. Okay, so what's the answer? So we know then, in this case, that the rubber band, if we want this thing to be obtuse, the rubber band has to shrink, right? So what's the value then, what's the length of the rubber band that makes this a right triangle? How would we find that? Yeah, Pythagorean theorem, right? Because this is a right triangle here. And so I could say x squared plus 77 squared equals 85 squared. And just solve for x, right? What would I do to solve for x squared there? I could turn these into numbers, right? Okay, so if I do that, you get big numbers. 85 squared is 7,225. So I get x squared plus 77 squared equals a big number, 7,225. What's 77 squared? 77 squared is also big. 5929. So now what would I do? Big numbers, but they're just numbers. What do I do to solve for x? Okay, good. Subtract 5929 from both sides. And that's going to give me x squared equals, well, let's see. 1296. Now what? Square root. So x, whoops. So x equals, if I square root that, I get 36. So the length of the rubber band right here is 36. If I want to make this thing obtuse, I've got to draw this piece, right, there's my hinge. This one's got to move down this way, doesn't it, to make that angle bigger instead, right? It's just moving in that big circle, right? Wrong color. It's just moving in that big circle, right? Because it's attached to that hinge. It's going to move down to there. So, important thing is, what's my upper limit going to be then? If I have to shrink this thing, x has to be less than what? No? 36. It could be 35.9999999. That's still going to be a slight movement, and it's going to make that angle just a tiny bit bigger than 90, isn't it? So the upper limit up here is going to be AC, which we're calling x, is less than or equal to 36. That's the hard part. That's the hard part. The rest is easy. Now, what's the lower limit going to be? What's the smallest that x could be? Well, what is the smallest that x could be? What's its lower limit? It's got to be bigger than what? Say it again. No, it can't be bigger than, if it's less than 36, it can't be bigger than 77. No. What's going to happen if I keep on shortening this? At some point, this is going to be straight down, isn't it? And this segment right here that's 85 is going to have swung all the way down there. This looks an awful lot like a triangle that we drew a long time ago when we talked about the triangle inequality. We said if we had any triangle, I know that the length of the shortest two sides have to always add up to more than the length of the long side, right? So for example, if the longest side in a triangle was 12, and this side had a length of 8, and this side was x, I know that x has to always be greater than what? It has to be greater than 4, doesn't it? Because these two have to add up to more than that one, or you couldn't make a triangle out of it, right? So x would have to be greater than 4, which we get from 12 minus 8. So if we go back to this one, what's it going to be? Yeah, well, 85 is the length of the longest one. If this is 77, right, the other one has to be just enough, so 77 plus x is greater than 85, right? Right? So we could solve that pretty easily. If x plus 77, the short piece plus the medium piece, or medium side in that triangle, have to add up to more than 85, what do I do? Subtract 77, right? So x has to be greater than 8. Does that make sense? Okay? So that's my lower limit, right? That's the lower limit. X has to be greater than 8 and less than 36 to make this an obtuse triangle. Okay, what if we wanted to make it acute? What would it be? Well, that would have been the opposite effect, right? That would have been, if we were making it acute, we would have stretched it, so it would have had to have been bigger than 36. But if we're told that, hey, ladies, if we're told that x is less than AB, which is 77, then we would have been greater than 36 and less than 77, right? Okay, make sense? Those are tricky. Those really are tricky. Okay, so what I wanted to show you for today is very, very simple. I want to show you a shortcut for certain triangles. There's two special triangles that we can deal with. We can deal with 30, 60, 90, and 40, 45, 90. And those are real common popular triangles, right triangles. 30, 60, 90. And they always have the same ratios between the lengths of their sides. Obviously you can have big triangles or small triangles, but if we're calling the length of the short side in this 30, 60, 90 triangle, the smallest side is going to be opposite the smallest angle. So if we call that x, then we can always calculate the lengths of the other two sides based on that one. It turns out that there are two magic numbers that relate the short side to the long and the medium sides. One magic number is 2. So to go from that side up to the long side, to the hypotenuse, we're just going to either multiply, if we're transitioning between those two sides, we're either going to multiply or divide by 2. Well, if we're going from the short side to the hypotenuse is bigger. Do I multiply or divide by 2 to make a number bigger? Multiply, right? So I would know then that the hypotenuse is just 2 times x. Okay, the magic number that links the short side to the medium side is the square root of 3. So the medium side is always going to be the short side times the square root of 3. Okay, so these problems are very simple. All they're going to do is they're going to give you one side in the triangle and ask you to calculate the other two. So just as an example then, what if I gave you this triangle? What if I gave you a 30, 60, 90 triangle, and I told you that the length of the shortest side was 10? What's going to be the length of the hypotenuse? What's the magic number that links the short side to the hypotenuse? 2. And I'm making it bigger, so I multiply. So what's it going to be? 20. Okay? What's going to be, I thought I heard it. So what's going to be the length of the medium side? This one down here. But we don't know. It's going to be a decimal. But what am I going to multiply by? Square root of 3. I'm going to multiply, because that's the magic number that links those two. And so if I just put that in a calculator, I'm going to get 10 times the square root of 3 is about, what? 17 point something. 17.32. We round it to 2 places. So there's the length of the medium one. What if I give you a different side? What if I give you, for example, I give you the hypotenuse this time. If I give you the hypotenuse is going to be 30. And I want to find the length of the short side. 15, yeah, because 2 is the magic number. I'm making it smaller, so I divide. So I get 15. What if I wanted to find the length of the medium side? Now, I can't go directly, based on that triangle that I drew, I can't go directly from the hypotenuse all the way to the medium side. I have to, first of all, I got to get to the length of the short side, and then once I get that, what do? I divide by square root of 3? Multiply. Okay, so to get from there to there, I'm going to take the short side times the square root of 3. That's going to be, I'm not even going to try. 30, well, no, I'm not going to. I won't waste time. 25.98. Okay? Okay, now what if, let's try one more of those. What if, you get the idea though. That's 60, that's 30. Let's say this time they give us the length of the medium side, and the length of the medium side is 10. And they want us to find x, which is the length of the hypotenuse. Think for a second. What am I going to do there? Okay, first I got to, in order to get up to here, I got to step through the middle side. That's my, or the short side. That's my middleman always. From medium to large, I got to first find the short side. The magic number is the square root of 3, but I'm getting smaller, so I divide. So we get 10 divided by the square root of 3 is about... No, I'm not going to. I want to get you down to the lab. It's too late in the week. My brain's shot. Everybody really can't do this stuff. 5 point. So if I were to round this thing a little bit, but you got to be careful with this. Now, I don't really. If I'm trying to get this answer, I almost did something here. I almost talked something bad. I don't want to round this answer because if I round it twice, I'm going to accumulate some rounding error that's going to make my answer wrong. So what I really want to do is I just want to call this one 10 divided by the square root of 3 and leave it at that. When I go up to here, I'm going to take that number and do what to it to get from the short to the hypotenuse? Times by 2, because 2 is the magic number and I'm getting bigger, right? So the answer up here is going to be x equals 2 times that, right? 2 times whatever 10 divided by the square root of 3 is. So how do I do that on a calculator without accumulating any rounding error? It's easy to do. What do you suggest? What do you think? These graphing calculators, now is when you can start to see the benefit of the graph. These things really do help with these big calculations. Come on. Okay, so look what we can do. If I want to calculate this number, I can just take 10 divided by square root of 3 and get a number. And it's really not, the reason it's doing that, that's really not the answer. I just need to put this thing on float. You should always have it on float in your calculator. So let me do that same calculation again. Okay. Look, it takes it out to a ton of decimal places, and it even takes it out to more than it shows you on the screen. So it does not round out. So that's this answer right here, right? That's the length of the short side. Now, what am I going to do to that to get the length of the long side? Times it by 2. So all I have to do on a graphing calculator is just hit times, and it'll take my previous answer, A-N-S means answer, times 2. And there it is. Now I can round it, because that's my final answer, right? That make sense? Okay, the only difference, there's one other triangle that's easier, and I'll just be very brief with this. The other triangle is a 45, 45, 90. It's easier because there's only one magic number. So in a 45, 45, 90, that's isosceles, right? So if the length of one of these legs of the triangle is x, what's the other one? No. If it's isosceles, what do I know about the, right, the angles are congruent, the base angles? They're the same. So that's going to be x, right? So those are always the same. And the magic number that links the legs to the hypotenuse of a 45, 45, 90 is the square root of 2. So I'm either multiplying or dividing by the square root of 2, and that's it. It's really simple. So if I start off with one that has a hypotenuse of length 20, if it's a 45, 45, 90, it doesn't look like one, but pretend it is. And I want to find that, for example, and that, what do? What's my magic number? Square root of 2. I'm making it smaller, so do I multiply or divide? Divide. That's it. Just 20 divided by the square root of 2 in a calculator. Okay? Make sense? Got it? Okay. Let's go. 205, I think, is